Hey there, fellow coders. Welcome back to my coding days with Mohammad. Today we are diving into essential topics in programming, literals. Don't worry, it's not as daunting as it sounds. We'll explore what literals are, the different types, and how they work. So let's get started. What are literals? Imagine you have a value that is so obvious it speaks for itself, like the number 91, or character A, or string hello. Well, in programming, that's called a literal. Every literal has a type, and its form and value determine that type. Integer literals are values that represent whole numbers in C++. They are pretty straightforward to use and come in three different notations. Let's explore each of them. First up is the decimal notation. That is the standard way of writing integers without any fancy prefixes. For instance, the number 91 is an integer literal in decimal notation, written simply as 91. Next, we have the octal notation. It's denoted by a leading 0 followed by digits ranging from 0 to 7. For example, 024 is an octal literal representing the decimal value 20. The third notation is hexadecimal. It's distinguished by a leading 0 lowercase x or 0 uppercase x, followed by hexadecimal digits ranging from 0 to 9 and A to F. An example of a hexadecimal literal is OX14, representing the decimal value 20. Now let's talk about the default types of these integer literals. Decimal literals are signed by default, whereas octal and hexadecimal literals can be either signed or unsigned. The type of an integer literal depends on its value and notation. For decimal literals, they can have the types int, long, or long, depending on the size of the value. Octal and hexadecimal literals have even more options. They can be int, unsigned int, long, unsigned long, or unsigned long. We can override the default type of an integer literal by using the following suffixes: lowercase or uppercase u for unsigned int, lowercase or uppercase l for long, and lowercase or uppercase ll for long. Let's have a look at integer literals in code. Thanks to type info library, we can check the type of any literal using the name method of type ID operator. Here we are checking the type of three integer literals with different notation. Here we have the decimal notation, following by the octal notation, and finally the hexadecimal notation. And here we are overriding the default type. Here we are overriding the default type by an unsigned int using the u suffix. Here we are making it long, and here using the ll suffix we are making it long. Here you see the result of running the code. We see that 91 is an integer, and the same as the 024, OX14, all are integers. And 64u is an unsigned int, 85l is a long, 70ll is an 64-bit integer which is long. Floating point literals are values representing real numbers with fractional parts in C++. They can be written with decimal points or in scientific notations. First up is the decimal notation. Just like you would expect, these literals are written as regular numbers with a decimal point. For example, the value of pi is 3.14159, which is a floating point literal in decimal notation. Or a simpler example can be 100. Please note the decimal point at the end of 100. The second notation is scientific notation. This allows us to represent large or small numbers concisely using an exponent. We use uppercase E or lowercase e to indicate the exponent. For instance, 1e3 or 1 uppercase e3 is equivalent to 1000 with a decimal point at the end. By default, floating point literals have the type double. So whenever you write a floating point number without a suffix, it will be treated as a double. But if you need a floating point literal of a different type, don't worry, you can easily override the default by using a suffix. The suffixes available for floating point literals are straightforward. To specify a float, simply add an F or uppercase F at the end. For example, 3.14159 F denotes a float. You can also use L or uppercase L suffix to specify a long double literal. For example, 3.14159 L represents a long double. Let's have a look at these in the code. Here we can see two floating point literals with floating point notation and one floating point decimal using the exponent notation. And in these two lines we are overriding the default by F and L suffixes. So by running this code, I would expect to see the type of these three literals are double, and the type of this literal is float, and the type of this literal is a long double. Let's see. Yeah, as expected, the types are double, float, and long double. Character literals represent single characters in C++. They allow us to work with letters, digits, and special characters like \n for new line and \t for tab. To denote a character literal, we enclose the character within single quotes like A or 7. The type of a character literal is simply char. It can hold any single character from the character set, which includes letters, digits, and various special symbols. Prefix L can be used to indicate a void character. While most characters can be used directly as literals, there are some that have special meanings in the C++ language. For example, the single quote itself and the backslash have special uses. To represent such characters, we use escape sequence. An escape sequence is a combination of a backslash and a character that represents a special meaning. For instance, \n represents a new line character and \t represents a tab character. For a complete list of escape sequences, please visit this link. I will put this link in the video description. Let's have a look at the character literals in code. Here we have a simple character literal, and we expect the type to be char. In the next line, we have used L to override the default type, so we expect the type of this literal to be void char. Let's run. And we see that A is a char and 7 is a char and LA is a void character. String literals represent sequences of characters in C++. They allow us to work with text and words, making our programs more interactive and user-friendly. To denote a string literal, we enclose the sequence of characters within double quotes, like hello or MyCodingDays. The type of a string literal is an array of constant characters. This array holds the characters of the string, and the compiler appends a null character, which is \0, at the end to mark the string's termination. Don't worry about constant, qualifier, and array if you don't know anything about them. I will create some videos about these topics in future. One cool feature of C++ literals is the ability to concatenate them easily. If multiple string literals appear adjacent to each other, separated by spaces or new lines, they are automatically joined together into a single string. This is quite useful when we need to write long strings that span multiple lines. Just like we saw with character literals, escape sequences can also be used in string literals to represent special characters. For example, \n represents a new line character and \t represents a tab character. Let's see the string literals in code. Here we have a string literal and we expect the type to be const array of character, and in this line we are concatenating three string literals by using a space and new line. Let's run the code and see what happens. Here we see that MyCodingDays is a character const 13. This 13 indicates the size of the array. As we said, you may have noticed that MyCodingDays has 12 characters, but compiler appends a null character at the end to indicate the termination of the string. And we see that these three string literals have been concatenated together. Boolean literals in C++ are special values used to represent true or false conditions. Unlike other literals, they are keywords in the language and not enclosed within codes. The two possible values are true and false. If you don't know anything about keywords in C++, please don't panic, since we'll talk about them in future. The type of a Boolean literal is, not surprisingly, bool. It's a data type specifically designed to hold either true or false values. Boolean literals are essential for decision-making in programming. Boolean literals find extensive use in conditions and control statements. They allow us to control the follow of or program based on certain conditions. Let's take a look at some examples in the code. Here we have two Boolean literals, true and false, and we expect the type of both to be bool. Let's run the code, and that's correct. If you found this video helpful, don't forget to give it a thumbs up and subscribe to MyCodingDays for more coding adventures. And as always, feel free to leave your questions and comments below. Happy coding, everyone! Thanks for joining me today on MyCodingDays. Until next time, keep coding, keep exploring, and have a fantastic day. See you in the next video.